this video, we're going to talk about velocity and acceleration. So we know that acceleration obviously is the change of velocity. We know that if we have a car, let's talk about, let's say it's ideal conditions, right? We have a car. This is my car. It's a very well-drawn car. And the car is moving at a set velocity. Let's say 5 meters per second, right? That car is going to keep moving at that velocity forever, unless a force acts on it, right? So in ideal conditions, and this is Newton's first law, it's that an object at rest will remain at rest, and an object in motion will remain in motion, unless some sort of a force acts on it, right? So an object that's traveling at a constant velocity means it has no forces being applied to it, right? So a ball rolling on a flat surface, that's supposed to be a flat surface, that ball is just going to keep rolling on that flat surface until either it hits something or until some sort of a force acts on it, right? Now we know that in the real world, things experience friction and they experience air resistance. But when we talk about physics concepts, particularly on the MCAT, we generally ignore friction and air resistance, again, unless the problem specifically deals with those concepts. So anyway, so an object will remain in motion, so constant velocity. If we want to accelerate something, if we want to change its velocity from, say, 5 meters per second to, let's say, 10 meters per second, that requires acceleration, right? And acceleration is in units of meters per second squared. So the equation there are three equations that we should know as far as for acceleration. The first is velocity equals acceleration times time, right? That is to say, velocity in meters per second is equal to acceleration, which is in meters per second squared, times time, which is in seconds, right? So the units make sense, right? And what this equation will do is this equation will help us to relate these three variables, velocity, acceleration, and time. Okay, good. Now, another equation that we want to use for the MCAT is we want to use the equation distance equals 1/2, or I guess sometimes this is also written as this, AT squared over 2, right? And so what this equation does is this equation relates for us these three variables, distance, acceleration, and time, right? So we see it's different from velocity, acceleration, and time. This is distance, acceleration, and time, right? Okay, good. So this is the second equation that we should know. And then the third equation that we should know as far as velocity and acceleration is this one, 2 times, or 2, not 2 times, 2AD equals VF squared minus V initial squared. VF is V final minus V initial squared, right? And so what this equation tells us is this equation gives us a change in velocity over a given distance, right? So if we accelerate over a given distance, what's the final velocity compared to the initial velocity? And actually, these three equations are very related. They can be used to derive one another. And so, but mathematically speaking, that's beyond the scope of the MCAT, and it's really unnecessary for us to know. However, if you find that you enjoy understanding derivations, then there are some pretty good explanations of that. So these are the three equations that we should know, right? And so these equations give us a feel for when things are moving and they're accelerating, change in velocity over a given distance and over a given time. So let me give an example of what we mean by this, right? So let's say we've got a ball, right? Actually, let's actually do this. Let's move these equations so that we can still see them. Let's move these equations to the corner. Move them to the top. Right, and then we can erase this stuff. All right, so let's do an example. Let's say we've got a ball. This is our ball. And let's say it's falling down, right? And let's say it's, I don't know, let's say it's let's say it's at rest now, but now let's say it's falling over a distance of 25 meters. What's its final velocity, right? What's its velocity going to be when it hits the ground? And so which of the equations are we going to use, right? Well, we know that we want the equation that removes time, right? We're not given a time, we're not given the amount of time that the ball falls, so we want the equation that doesn't use time. And which equation is that? That's this third one, right? So 2 times acceleration. And what is acceleration here? Acceleration here is, whenever we talk about gravity, acceleration is 10 meters per second squared. Right? Units of acceleration are meters per second squared. So 10 meters per second squared over a distance of 25 meters, right? And that is equal to Vf squared. Obviously mine is Vi squared, but in this case V initial squared is 0. So V initial is 0, so we can just remove that. And typically on the MCAT, you will only need to use one or the other, V initial or V final. So 2 times 10 times 25. So what is that? That is 20 times 25. And that is equal to 500 equals Vf squared. And so the square root of 500 is equal to Vf. So the final velocity is the square root of 500. And so this is one example. So we might be given, again, if we're given a distance, or we're given acceleration, we're given a distance, then this is what we want to do. We could do the opposite, right? Let's say we launched a ball up in the air, right? How high is it going to go? Let's assume we launched it at let's say 30 meters per second, very fast. 30 meters per second. We launched the ball up in the air. How high is it going to go, right? So again, in this case, we're not given time, so we want to use this equation over here, right? So V final, of course, is 0, so we can remove that. So negative V initial, right? Negative 30 squared is equal to, I just moved them to opposite sides, is equal to 2 times acceleration, which is 10 times distance, right? So negative 30 squared, that's negative 900 squared, or 900, sorry, not squared, equals 20d, right? And then we would do the math on that, right? The math doesn't really work out that nicely, but typically on the MCAT, the math will work out fairly straightforward, or they'll give you the answer in terms of, for example, in terms of square roots or something like that, right? So, yeah, actually, no, the math is pretty easy on this. Negative 450 equals distance, right? Or 45 is equal to distance, right? So 45 meters. So we went about 45 meters, right? Okay, good. So this is one of the things. And then the last thing we want to be aware of is velocity is equals to acceleration over time. If we accelerated, say, 5 meters per second squared, it's supposed to be a 5 meters per second squared over a time of 20 seconds, and you just multiply those, right? And so it's really straightforward. These 3 equations are 3 equations that we can use to manipulate velocity, distance, and acceleration in various forms. And time, I forgot about time. So velocity, distance, acceleration, and time. And so typically, depending, you're going to figure out which equation to use, and you're going to use that equation. The last equation to be aware of, and this is a little bit, we'll talk about this more in a future video, but the last equation to be aware of is, of course, I'm going to write it in a different color so we're aware. F equals ma, right? Force equals mass times acceleration. So this is a different equation. It's a different concept. It starts getting to the concept of force, and it's a little different. So we're going to take a look at some practice problems related to this concept, and we're going to see maybe how to apply these concepts to the practice problems.